Hello, and welcome to McGill Academy's first video, Module 0, Introduction to Solidworks. Prior to beginning, I'd like to extend a warm welcome to you and all of those who are using our new service. It's with your support and your improvements that we continue to thrive as an EOS club. So if you have any concerns in that regard, please don't hesitate to let us know. Furthermore, we offer live help as part of our Discord server, which is filled with a group of our tutors as well as executives. So if you have any questions, please don't hesitate to jump on there and ask away. Before you start up SolidWorks, you need to ensure that you have the software. To do this, you need to contact EMF if you're trying to download the software on your own. EMF is the Engineering Microcomputing Facilities at McGill, and they will hand you a license if you'd like to use SolidWorks at home. Otherwise, if you use a computer on campus, you should be fine. All right. Now for the good part. So what I've done is I've started up SolidWorks, and it gives you three options to start off with. You can either make a part, an assembly, or a drawing. I'll explain the difference between the three of these. So a part is essentially one cog in the larger system. It's one singular model. It's whatever you want to design or sketch or draw, and it's one singular component. That's the key thing to remember. An assembly, on the other hand, is a conglomerate of parts. It's unified parts. And what helps with this format is you could edit your parts by themselves however you'd like, and then finalize them. And then once you go onto an assembly, you can pretty much paste in those parts and join them together and make one unified model without having to draw the whole thing from scratch. It helps with organization and file conventions. Lastly, you have drawings, which are essentially the engineering grade drafts that you're going to be submitting towards the end of this class. We'll cover those in a later video. But for the purpose of this video, I've selected a part. Now, one may ask me, how do you necessarily rotate an object? Well, I've got Bob here, and we want to see something on Bob's back. What you do is you hold down the middle mouse button, and you can rotate by moving your mouse around. This allows you to have more of a free way of looking at your object. Furthermore, you could press this View Orientation tab here for more concrete views, which will allow you to compare for symmetry and different other aspects of your model. Now, say you've got two different models that are sort of merging within one another, and you can't necessarily select one of their edges. Well, click this display style option here, and what it'll give you is multiple different ways of expressing your model, which may make it easier to work with your model. So say we have this wireframe design here. As you can see, any edges that are hidden by the camera view are still visible through these dashed lines, and you can still see your solid lines. It's fairly useful, and it's a tool I use quite often. Furthermore, you can either zoom to fit, so essentially it centers your object, as you can see here. You can also zoom to a particular area, and you could also select your previous view. Furthermore, if you want something similar to the wireframe design, but with your shaded object, you can press a section view and essentially move this in and out, and it creates a split section of your model. Again, this is quite useful, particularly if you have sort of like a convoluted assembly that you want to see within. Furthermore, let's say if you're getting tired of good old Bob here, what you could do is hide him by clicking on this future tree right here and pressing that button right there. So as you can see, this is either a hide or show button. It's quite useful, especially if everything's getting in the way. Now to talk about reference geometry and datum planes in particular. These different types of tools are the lifeblood of modeling as we know it. In particular, reference planes. So by clicking this reference geometry tab here, we can click planes, and what they allow us to do is, as the name implies, create a new reference for sketching and extrusions. So it allows you to create a 2D surface for which you can make drawings on. So say we want to select Bob's right side here, right? It gives you numerous tools here, but I'd like to talk about the offset in particular here. As you can see, the plane isn't quite touching Bob's surface, and this is due to this offset here, and you can augment that. Furthermore, you could change the number of instances or the number of planes that you have by augmenting this number. And as you can see, it says number of planes to create, and we've got this here. But for the purpose of our next tutorial, we'll keep it at 1. So we click OK, and as you can see here, it created a new plane. And let's deselect that, because this is going to lead to our next topic, which is sketching. So if you press the sketch tool, it'll ask you to input a 2D surface. You could either do any of Bob's flat surfaces here, but for the purpose of our reference geometry, we're going to click here. And you can align the view a little bit better. And notice that you have a new canvas for which to draw on. And that's something we're going to cover in the next video. But in the meanwhile, we'll exit the sketch and leave it as is. Finally, when you're about to leave your document, be sure to save it by pressing the File, Save, or Save As button here, as well as checking your conventions. So you can click the settings here. This allows you to look at the system options within your file and the different aspects of it. You could also check your document properties here. So this will allow you to change your units, for instance. That's quite important. For our purposes, we're going to be using IPS, so inch, pound, second, etc. Anyways, that's all for Module 0. Thank you very much for watching.